let's talk about angles. More precisely, let's talk about what an angle is and how to measure it. Okay, an angle consists of two rays with a common endpoint. The rays are called the sides and the endpoint is called the vertex. So here's a picture of an angle, and here's your vertex over here. That's at point A, and you've got a couple of sides here. Now, technically, the sides are rays, right? Because they add an endpoint and then they go off into some direction. So the sides here that we got are AB, which is the bottom one, starts at A and then extends out through B. You've got AC, which starts at A and then extends out into the direction of C. They meet up right there, which is what is called the vertex. All right, now you can name an angle a few different ways. The safest bet is to use 3 letters. Okay, now those letters are going to be the vertex for sure. You definitely need that. You're also going to choose 2 points, one that would be on each of the sides. Okay, so we've got point C here on that side. We got point B that is on this side. And what you can do is just list those 3 letters. This is the angle symbol right there. You can write the angle symbol and then you write the 3 letters that would be there. But the important thing that you do about this is you make sure that they go in the order that you would draw the picture if you weren't picking up your pen or pencil. Okay, so this one says BAC, which, you know, if I didn't pick up my pen, I could start at B and then draw a line to A, make that turn over to C. I never actually had to pick up my pen to do that. Okay, so then you can do the opposite direction as well. You could start at C, go to A, and then turn over to B. Okay, so you can write it either way like that. So you got angle BAC. That would be the same angle as angle CAB. Okay, but you cannot call it like angle ACB, or you can't go alphabetical just because that would sound convenient and call it angle ABC. That would be wrong. You need to make sure that they go in the order and how you would draw this if you were not picking up a pen. Now, if the picture is not really complicated, like in this case, all we do is just have a simple picture of an angle. You don't have to use all of the letters that we did in those. You can just simply call it angle A. And it's fine, and from that picture, we'll know what it means. We don't need all the letters that go with it. Now, when you start looking at more complicated pictures, you got more things that are involved there, you might not be able to do that. There might be a couple of angles that are using point A as the vertex, and it becomes confusing trying to figure out which angle we're actually referring to. In that case, you should go with one of these two. Just go ahead and name 3 letters, play it safe. Example number 1 is going to ask us to name all the angles that we see in this diagram. So the first thing here is we should probably figure out how many angles there actually are. All right, and the answer to that is 3. Okay, you've got this large angle that covers everything. You've also got these 2 small ones that would be inside of it because you've got that break if you look at that ray that's down the middle. So we actually got a total of 3 of them. All right, now naming them. The first point here is you can't do this. You can't refer to any angle as angle X. Can't do it, it's off the table. We don't get to use this one. The problem is that every angle that we have here is going to be using X as its vertex. So we want to stay away from trying to go too simple on that. And what we'll then do is just use 3 letters. All right, let's say we're talking about the largest angle that we got here. For that one, you can call it angle WXZ. Just make sure that your vertex is the second letter because you'll have to start from a side to the vertex to the other side. Now, if you want to flip that around, you can do that. Now, it's not a different angle. It's the same angle. It's just a different way to name that largest angle that we have there. All right, the other 2, we could do the top part. You got WXY. You can do that. Now, you can also switch the letters. I won't really worry about writing it, but you can switch the orders around if you want. Then last, you could do YXZ. Do that. All right, so these would be the 3 that would be in there. You have the reverse order of the letters that you can use to write them, but it would technically be the same angle. So previously we had looked at the ruler postulate, which was a way to measure the length of a segment. Now, measuring angles, what we have is something called the protractor postulate. And basically all that means is that you can use this instrument, a protractor, you can use that instrument to measure the size of an angle. The general rules to this would be that Every protractor has like a middle point or a center point. That center point needs to be right at the vertex of the angle. You want one of the rays of the angle to rest along that straight line that you have here, which we call the zero line here. It doesn't really matter if you got it matching to the left or the right, because you're going to have an outside set of numbers and you're also going to have an inside set of numbers. So it's, as soon as you get used to making sure that you're using the right set of numbers, it's fine. But you definitely want the vertex here. It's also going to make things easier if you do have it lined up with the baseline, because then you can just pick out the angle that goes with it. Now, before we start measuring angles with a protractor, what we're going to do is learn how to classify the angles. Okay, and you classify angles by the general size that you have. And if you get used to what these classifications are, it does become helpful in being able to visualize what type of an angle we'd be looking at. Okay, so for all these pictures, we've got a horizontal, and let that sort of be a line that's already there. You've got another side to the angle that is going to open up wider and wider as you go through the pictures. Okay, so we're talking about the space that would be between the sides. That's what we're measuring when we measure an angle, is how far apart those sides are. Okay, in this picture, they're not too far apart from each other. They're definitely not far apart from each other if you start to look at what's happening in the next ones. Okay, now if that line starts to get further away, it'll eventually be pointing vertical and we get what's called a perpendicular here. Okay, so you got a little angle. After that, you've got where it's perpendicular straight up. Then it continues to open up a little bit wider. So now you're getting a large angle, and then you can get it to open all the way until it's pointing to the left, which would just give you a flat line. All right, so here's the names that we've got. The little angles, these guys are going to be called acute. They're called acute angles. This that we have where there's a perpendicular, and you'll see a little box there, that would be exactly 90 degrees. That's the measurement that we see. In fact, I'll go ahead and just put the protractor on so you can notice that. Okay, so I got the vertex at the center. I got the base of the zero line, and then you're going to see it points up to 90 degrees. So if you have a 90-degree angle, that is called a right angle. Okay, so acute has a range. It's going to be bigger than 0 but less than 90. Okay, so A's got to be bigger than 0 and it has to be less than 90. This case, A is going to be equal to 90. All right, and the next, once you're passing 90, you get into what is called obtuse. And an obtuse angle is going to be greater than 90, but it's going to be less than what we get here, which is 180. Once you get to being perfectly flat, that's 180 degrees. So this last one is going to be called a straight angle. And that is when A is equal to 180. Let's go ahead and put some degrees on all of these. All right, so acute is the little ones. Right is going to be exactly 90 degrees, and then transition between acute and obtuse. And once you open your angle as far as you can, that would be called a straight angle, which is 180 degrees. In example number 2, we're going to practice using a protractor. Well, sort of. We're not exactly going to get out a protractor and place it on top of the image and measure things, because we've already got the protractor that's there in the background. But what might be a good thing to look at here is imagining what this would look like without the protractor on there. You would have this line here, which has points G, H, J on it. You have those points, and then extending from H, you've got a couple of rays with some points that are on them. So if you took out the protractor, I think you'd still be able to see that the best location to think of as the vertex would be where point H would be. So that's why your protractor is going to get centered here. Now what we're going to do is figure out the measure of each of these angles. We're also going to go ahead and classify those. And we're going to classify them as acute, obtuse, right, or as a straight angle. All right, so angle KHJ, it's right here. You start at point K, you go to H, which is going to be the vertex, and then to J. In fact, you're going to notice that the vertex in each of these is all going to be H, because that's where the protractor is centered at. All right, so KHJ. What we want to do first is follow that side out to the edge to make sure that we're going to end up looking at the right numbers. So you've got a 0 and you've also got the 180. Okay, and we're going to be measuring this space here. So we're going to want to start at the 0. You can technically use the outside numbers, it just makes it a little bit harder to work with, so I would try and identify which set we should be using. So we're going to start at 0, and then it goes up to 10, 20, 30, 40, 50, and that looks, I guess it's going to be at 55 degrees. All right, so KHJ is 55 degrees. Now, what type of an angle is that? That would be one of our little ones, which is going to be acute. All right, GHK. GHK, this is sort of interesting here because if you look at the protractor as a whole item, it measures out to 180 degrees. And what we did is we just measured this space here, this KHJ, we measured that as 55. The next angle that we're looking at here, GHK, is actually the rest of that thing. So one option you have here, since we already know the 55, is you could subtract that 55 from 180 and you'd get an answer. Or what you could do is follow this line out, make sure that you're looking at 0, which will now be the outside. Okay, and then the numbers are going to count up 10, 20, 30, skip a whole bunch of them. Eventually, we get up to 110, 120, and then it's at 125. And again, these two are going to add up to 180. So that was a little unique thing that we had there, that together they make the full 180. All right, and that being greater than 90 degrees is obtuse. That's an obtuse angle. All right, so GHL, that's the easiest one that you're really going to get here. That is right at 90 degrees. It doesn't matter. I mean, you should be measuring from here out to it, but you know, the other side is also 90 because it's 180 split in half. All right, so that is going to be 90 degrees, which is called a right angle. All right, and then KHL. Okay, so that's an interesting angle that we have there because it doesn't actually line up with one of the baselines there. Now, if you actually had a protractor, what you could do is you could take your protractor and center it at H and then line it up with the K. You could line it right there, and then you could use this is really hard to see with my protractor on top of theirs, but you could use the numbers that are on our protractor, this plastic one, to measure that one. Now, that's probably going to be too messy to look at. What we could actually do in this case, recall that KHJ was 55, that this was 55 degrees here. Up to L is going to be 90 degrees. So if we take 90 and subtract 55, what we will get is 35. So that'd be a 35-degree angle, which is also acute. You might not need to do all that math either. You can probably just count the spaces. You've got 10 degrees, 20 degrees, 30 degrees, and then another 5. So there's different ways that you can go about getting the answers. So previously we'd seen something called the segment addition postulate, which had said that if you took two segments that were back to back, you could take their individual lengths and it represents the length of the longer segment when they're put together. The same thing is true about angles. If you were to put two angles side by side with each other, their measurements, their individual measurements, would add together to give you the measurement of a larger angle. Okay, now the most important thing though is that the angles, when you do put them side by side, that they do have the same vertex. Okay, so if we take RSP, the measurement of that spot right there, RSP, and you take the measurement of the one that's underneath it, PST, you take that measurement. If you add those together, you're just going to get the measurement of RST, the whole thing together. So as long as they're side by side and they share the same vertex, then you can add their angles and get a larger one. Again, this is a postulate, something that doesn't need to be proven. Most likely, that should just make sense to you. That should seem logical. All right, so what do we have here? RSP, which is here, PST, which is there. So that's going to give you RST. All right, and a little bit more about notation here. You're going to notice that you got these little m's in front of the angle symbol. Okay, so if I take the m off of it, that would just be read as angle RSP. Okay, but then we got this addition symbol here. We got this addition, and addition is something that you do when you have numbers. You have things that are valued. Okay, so what we really need to do, and this is just a super technical thing here, you're supposed to put a little m in front of this so that we can read that as the measure of RSP. And now that quantifies it. It gives it a number value so that you can then add it to another number value and in the end get a number value. So it's a little technical thing here, but if you are going to be adding angles together, if you're going to be talking about the size of the angles, you should have these m's in front for measurement. So example 3 has a picture of a couple of angles that are side by side with each other. And we are told that the measure of LKN, notice that it's got measure because we're going to give a value to this. The measure of LKN is 145. That should say degrees. We'll just add that on there. All right, so LKN is the whole thing. The whole thing is 145 degrees. And what we need to do is figure out the measurement of the two little ones, LKM and MKN. We got to figure out those two. Okay, but using the angle addition postulate, what we can do is take what you'll see here as expressions. You can take the expressions that represent the two small angles. We can add those together and set it equal to the 145. So we're going to take 2x plus 10. I'm going to leave parentheses around it just for a sec here so you can see what the overall idea is. We're going to take the two expressions for each of the angles. So I kept them contained in their parentheses. We'll add those together and then their total should be 145. Now mathematically, like as we move through the problem, you don't need the parentheses. We're just going to drop those off and we're going to start grouping terms. So really we've got a 4x plus a 10 plus a 4x and a minus 3. So if we group these appropriately, you're going to have the 2x and the 4x together as 6x. You're going to have the 10 and the minus 3. So if you subtract 3 from the 10, you're going to get plus 7. And that can be set equal to 145. We'll then subtract 7 to get rid of the constant. So 6x is going to be equal to 138. And after that, we'll divide by 6, which will give us x. So that'll give you 23. All right, now that we've got the 23 for the x, what we can do is take that and go ahead and just plug it into the expressions that we've got here. Okay, so you're going to have 2 times 23 plus 10. You're also going to have 4 times 23 minus 3. And when you get those answers, what you should do is add them just to make sure that they turn out to be 145. A little quick way to check your work here. All right, so I'll just go ahead and type these in. All right, so we got 2 times 23 plus 10 is going to give us 56. We also got 4 times 23 minus 3, which is going to be 89, and 56 plus 89 is 145, so everything seems to look pretty good there. All right, so stating our answers here. Kind of ran out of space, I'll need to put it over here. The measure of angle LKM is equal to 56 degrees. The measure of angle MKN is going to be equal to 89 degrees. Those would be the answers. Didn't have much space to write this, so I'll just squeeze them in over there and box them up. Last, what we need to talk about is congruent angles. Okay, congruent angles are angles that have the same measure. Now, similar to when we talked about congruent segments, what we're really going to be looking at doing here is making sure that we are good with markings and notations and different statements that you're allowed to write. Okay, so in the box, what we're going to see here first is a picture of two angles. So we got angle A, we've got angle B. And you're going to notice that they've got these little marks that would be in the corners of them. Now, it might be hard to tell here, but these are not just like straight lines. They actually have a little bit of a curvature. They're actually called arcs that would be in there. The fact that A and B both have a single arc in that spot, because you could actually draw one next to it to identify different pairs. Because these have one mark each, it tells us that they are congruent to each other. So that's the marking that you would use in a diagram. Now that we know that these two are congruent, there's a couple statements that you can write. Let's start over here with the congruent statement. Okay, so angle A is congruent to angle B. That is just indicating that the size of the shapes are the same. Okay, now if we're going to get a little bit more specific and talk about the fact that they have the same angle measurement, you can write this statement. You can say that the measure of angle A is equal to the measure of angle B. By putting that little m in the front, which we read as the measure of, okay? By putting that in front of it, we're actually giving this some sort of a numerical value. And numbers can be equal, but shapes can be congruent. In example number 4, we get to learn one more new word here, which is bisects. To bisect something is to cut it equally in half. Okay, sometimes we just say cut it in half, but we're being very precise here. When we say cut in half, we mean it's actually cut into 2 equal pieces. Okay, so up at the top it says, in the diagram, YW, ray YW, that's this one here, bisects angle XYZ. So that means that that ray is going right down the middle. It's going to split it so the top half is the same size as the bottom half. Now, to help communicate that information in the diagram, you're going to notice that you've got these single markings. Okay, they are a little bit offset from each other. That's just so we don't look at it as one big mark that goes through there. But we've got a single mark up there. We have a single mark in the bottom. So that's going to indicate that they are the same size. And we are told that the measure of angle XYW is 18 degrees. And we're asked to figure out what the measure of angle XYZ is. So XYZ is the whole thing here. Okay, well, if that is a bisector, then you've got 18 degrees here. So the whole thing is going to be 18 and 18, which means that the answer is 36 degrees.
Wait, what?